Is chemical potential the same as concentration or pressure? Imagine you're at a busy market, and you're trying to figure out what makes certain goods move from one stall to another. In the world of chemistry and thermodynamics, similar ideas help us understand how particles behave. Today, we're exploring whether chemical potential is the same as concentration or pressure. Let's start with what each term really means. Chemical potential is like the energy a particle has in a system. It tells us how much energy is needed to add or remove a particle, assuming temperature and pressure stay the same. Think of it as the particle's desire to move or stay put based on its energy level. It influences how substances distribute themselves and reach balance. Concentration, on the other hand, is simply how much of a substance is present in a given space. If you have more sugar in one glass than another, the first has a higher concentration. It's a straightforward measure of quantity per volume or mass. Pressure is the force exerted over an area. Imagine squeezing a balloon. The pressure inside pushes outward. In thermodynamics, pressure affects how particles behave, especially in gases and liquids. It can change how particles spread or react. Now, how do these ideas compare? Chemical potential is affected by concentration, but they are not the same. For example, if you increase the concentration of a substance, its chemical potential generally rises. But chemical potential also depends on temperature and pressure. So, two solutions with the same concentration can have different chemical potentials if their temperatures or pressures differ. Similarly, pressure influences chemical potential but isn't the same thing. When pressure increases, it can raise the chemical potential of a gas or liquid, making particles more eager to stay in place or move. But pressure itself is just a force per area, not an energy measure. In the context of entropy and spontaneity, chemical potential helps us understand if a reaction will happen on its own. If the chemical potential of reactants is higher than that of products, the reaction tends to proceed spontaneously. This is similar to heat flowing from a hot object to a cooler one until they reach the same temperature. Understanding chemical potential is key in many practical areas. It explains why substances move between phases, like from liquid to vapor, or why reactions occur in certain directions. It acts as a driving force, much like pressure pushes gases or heat moves from hot to cold. So, to answer the question directly, chemical potential is not the same as concentration or pressure. It is a measure of energy related to particles in a system, influenced by both concentration and pressure but not identical to either. It's a more complete picture of how particles behave and how systems reach equilibrium.